Okay, so 7-4 is called rational exponents. Okay, so if I say rational, what are we talking about? Not necessarily, no. No, not necessarily. Could be positive or negative. There you go. Okay, so a rational number is a number that you would write as a fraction, and then exponents, we're talking about the exponent, obviously. Okay, so we're going to have fractions up in the exponents. Okay, so what we're going to do is we're going to start by taking our radical form and understanding how to convert it to exponential form. Okay, so I'm just going to give you a generic definition here. Let's say we have the nth root of a to the x. Okay, so this is our radical form, which we're used to. Okay, if we convert that to exponential form, whoops, it would be a to the x over n. Okay, so notice that the exponent just went on the top of the fraction, and then the root went on the bottom of the fraction. Okay, so just a quick couple examples of that. Let's say we have a to the, whoops, sorry, I didn't want to do this. Let's say we have the square root of a cubed. Okay, and we're going to convert that into exponential form. What would the exponential form be? Yeah, hold on, let's take a pause here. I see like 10 people on their phones. Everybody take your phone. I'm going to talk for 15 minutes. And we do this. Put the phone down for 15 minutes. Okay. I know, it's tough. Okay, so a to the power of 3 halves. Okay, so the exponent goes on the top. The root, since it's a square root, goes down on the bottom. We good there? Should we do one more? Because I feel like not everybody was with us on that one. How about, let's say we have the 5th root of b squared. What would the exponential form of that be? You can just shout it out.
2/5.
Okay, good. b to the 2/5. Okay, so the 2 goes on the top, the root goes on the bottom. Fair enough? Simplify with numbers? Yes. Okay, so this is what they're going to do with numbers. They're going to give you something like, we'll just call this example 3. They'll give you 125 to the 1/3. Okay, so if I start, what's that? Yeah. Okay, so if I start with exponential form, the first thing I want to do is I want to convert it into radical form so that I can break it down. Okay, so what would this be in radical form? Good. Okay, so this is the cube root of 125, and now we can break that. So what is the cube root of 125? It is 5. Good. Okay, let's try another one of those. Okay, let's say we have 16 to the 1/4 power. Okay, what is that in radical form? Okay, good. So we have the 4th root of 16. Anybody know what the 4th root of 16 is?
We do.
It is 2. Good. Perfect. Okay, so now what I'm going to do is give you some properties, and these are going to all be the properties of exponential expressions. Okay, so I'm going to give you 6 properties. Here's the first one. If I have a to the m times a to the n, as long as the 2 bases, the a's, are the same, what can I do with the exponents? Close. No. No. How about I'll just tell you this one. you're going to add the exponents. Okay? M plus n. Okay, so versus the scenario if you have a to the m to the n. Okay, what would you do with those exponents? Okay, good. So this is the scenario where you multiply the exponent. So this would be a to the m nth. See the difference? Okay, what if you have two numbers that are being multiplied? Let's call them a and b. And they are multiplied to the nth. Okay, what would you do for that one? Good. Okay, so this one is kind of like the idea of distributing the n power in. It would be a to the nth times b to the n. Okay, so you can only distribute an exponent if the pieces inside are being multiplied. Okay, not added. That would be a FOIL scenario. Okay, we talked about this one before. If I have a to the mth being divided by a to the nth, what do you do with those exponents? Question?
Wouldn't you just multiply a times b? Because it's in parentheses.
Yes, you would, but the idea would be that the a and the b would both be variables, so you can't multiply them because you don't know what the values are. So you would see something like x times y. But if there was like 2 times 5, then yes, you would just multiply the numbers. Yes. Okay, so what's my number 4? If I have two numbers being divided, what do I do with the exponents? No, you don't divide them. No, you're just going to simply subtract. So you just subtract the exponents in this one. So m minus n. Okay, the fifth one is, let's say I have a fraction, a over b, to the nth power. Okay, how do you do this one? There you go. So this one is kind of like you're distributing that exponent through. Okay, and here is the last one. If I have a to a negative exponent, what happens if you have a negative exponent? No. It's not a square root. What? Okay, let me just tell you. So you simply, good, you just move it into the denominator. Okay, so if I have a negative exponent, it moves it from the top down into the bottom. Okay, so it creates a fraction. Okay, so another scenario you might see is if I have 1 over a to the negative nth, if the negative exponent is in the denominator, what's going to happen? Yeah, it goes to the top, exactly. A to the nth. Okay. All right, so let's play with a couple of these. Okay, so number 1, let's say I have 25 to the negative 3 halves. Okay, so for starters, if I have a negative exponent, what's happening? Where is it going to go? Goes into the bottom. Okay, and since I have 25 to an exponent, I'm going to convert it into radical form. So what is the radical form that's going to be on the bottom? Go ahead.
Square root of 25 cubed.
Close. Just a positive 25. So the only thing the negative does is simply move the whole piece down into the denominator. Okay, so now I have to reduce this. Now I will tell you that it is always easiest to make things smaller and then go bigger. Okay, so if I break the radical down and then cube it, that will be easier. Okay, so what is the square root of 25? Okay, so 5, now what is 5 cubed? 125. So this will just become 1 over 125. Okay, how about this one? If I have 32 to the 3/5 power, what would you do? What's my root? The 5th root. Good. 5th root of 32 cubed. Okay, so again, break the root first. So what's the 5th root of 32? 2. Nice. So what's 2 cubed? 8. Very good. Okay. Let's try one with some variables. How about x to the 4th, y to the -5th, and z squared. Okay, so what am I going to do with this one? What am I going to do with those exponents and that 3 that's out? Good, I'm just going to multiply all of the exponents by 3. Okay, so this is going to give me x to the 12th. What's -5 times 3? -15. And z to the 6th. Can I leave it like that?
Nope.
Okay, so why not?
Negative.
Okay, so what am I going to do with my y piece? Good, perfect. Okay, so only the y is going to move because it's the only one that has the negative exponent. Okay, so just the y moves down. That make sense? Pretty easy there. Okay, here's my last example. X to the 5th times y to the -7th over x to the -2, y cubed, all squared. Okay, so what am I going to do for this one? Okay, now you absolutely can start by multiplying them all by 2. Absolutely. I'm going to go the other way, though. I'm going to simplify, because I always think it's easier to make things smaller first and then get bigger, but it wouldn't be wrong. You'd get the same answer. Okay, so I'm going to start by reducing the fraction. If I have x to the 5th over x to the -2, what do I do with the exponents? Subtract them. So what's 5 minus -2? X to the 7th. So I have x to the 7th. Okay, and then my y, I have y to the -7th over y to the 3rd. So what's -7 minus 3? -10. So if I get a -10, where can I put my y? Okay, so I can put it into the bottom and then make it a +10. Okay, because I had -10, it just moves it downstairs. Okay, so now I can deal with the 2. What am I going to do with those 2 exponents? Just multiply them. So I'm going to get x to the 14th over y to the 20th. That one make sense? When they're being divided, yep, exactly. Yep. All right. What's that?
What if you just like, in the last one, you put the x on top, the y on the bottom, the y minus
Oh, initially? Yeah, you would get to the same place. You could totally do that. Mm-hmm.